So, okay. So what we'll be going over today is nomenclature of chemical compounds. We'll be naming ionic compounds, non-metal compounds, acids, and doing additional exercises. So first we'll go over the basics of how to name it first, and then we'll do a few problems, and then we'll go on to the next section. Okay? Let me know if you want me to slow down or you need a minute to write down problems and so on. So the first thing we'll be going through is our ionic compounds. So ionic compounds are the metals. So here you can see the periodic table. If possible and you have a periodic table on hand, please pull it out. I'll give you a minute to, or just message in the chat or turn on your mic and let me know that you have your periodic table, because you'll be needing it for the following problems. Got it? Okay. We will start then. So the first thing in how to name ionic compounds is that you need to know that ionic compounds consist of a metal and a non-metal. So from here, we're going to name ionic compounds. So the first thing you need to recognize are that metal and non-metals together form an ionic compound. So to name it, you'll have the metal name, so something like calcium, and the non-metal name, and you'd add "ide." So let's do sulfur, so it would be sulfide. So this is sulfur plus "ide." So calcium sulfide, an ionic compound, your next one, is a metal with a polyatomic ion. So we can do sodium, and that's Na. Just put it here as well, calcium. And a polyatomic we can do PO4 3 minus, and that's phosphate. So this would be sodium phosphate. Good. Let me know if I'm going too fast. Thing that you want to note is that when a metal cation has one charge, the charge in the molecular formula must be indicated. So if you have an excess charge, has more than one charge. So like in this case, there's like, you can have iron 2 plus, iron 2, Iron 2, what that just means is that Fe has a 2 plus charge. And that's what they mean by when a metal, the cation has more than one charge. So what you can see here is sodium only has one charge. You don't have to indicate it. But if you were naming something with iron 2, you'd have to write iron 2 and then non-metal. Any confusions? You guys are good. Just let me know in the chat or anything. Okay. Are you guys good to go to the next slide?
Give me 1 second. Sorry.
Okay, no worries.
Okay.
Okay, let's go to the next slide. So how to write a molecular formula. When you're writing a molecular formula for aluminum and 3, this is here is the extra charge you have to indicate, and oxide. You'll write aluminum here. You'll write aluminum here, and you'll note that it has a 3+ charge. Oxygen here, it has 2- charge. So what you'll do is, so you'll cross them. This is like a technique. You'll cross the numbers. You'll put a 2 on aluminum and a 3 on oxygen. So then your product will be aluminum 2 right here, oxygen with a 3. In cases where, let's say Al, let's do sodium chloride. Na has a plus charge, 1 only, +1 charge. Chloride has a -1 charge. If they have the same charges, they'll actually cancel each other out in a sense. So you only have to write NaCl when you cross them. You guys see what I mean? Are you guys confused about how we get the charges?
Yeah, I'm a bit confused with that.
Okay, so let's look at oxygen, okay? So right here, oxygen has a -2 charge. I'm gonna go back to the periodic table. So what you'll notice here is that right here, what this means is that this column, we're looking at nonmetals. We're looking at nonmetals right here. This column, everything here. Dinner. Okay. Everything in this right here is basically everything in this column right here has a -1 charge. Everything in this column right here has a -2 charge. Everything for the nitrogen has a -3, -4 charge. And boron has a formal charge of -1. So boron is like an exception, is a -1. For non-metals, you'll go down a similar path right here. These, 2 different colors. Green. Can't see it. Okay. Right here, this column has a 1 + 1 charge. You'll actually note them here. There's 1, 2, 3. These kind of help. This column right here has a 2+ charge, +2 charge. So this is basically where we're getting that plus and minus charges to get the answers. You guys see it?
Yeah.
Okay, so I'm gonna go back to the problems, okay? So this is what we did. Does it make sense now, Josie?
Yeah, it does. Thank you.
Okay, Alexa, you got it as well?
Yes, it makes sense.
Okay. So the next thing is things to remember. So your group 1A and 2A metals have the same charge in all of their compounds. So that's what I went over right here. Where 1A, these all have 1 charge of +1. These all have a charge of +2. Oxygen will always have a charge of -2. The ones down here will also have a -2. And fluorine will always have a -1 charge. Same case can go down here. So chlorine, bromine, iodine, and aspartame will also have a -1 charge.
How do we find the charge of something like cobalt?
So cobalt, let's find cobalt.
Number
Where?
27 in the middle.
27. So cobalt in this case, actually, these are transition metals. So this transition metals has a special case. You'll just name them same way as cobalt, but it just depends because it can be cobalt 2 as well. It has to depend on which one you're using. So that's why that's a tricky one with the nomenclature. There should be a list, actually, your professors should give it to you when you guys arrive to naming. There's like this list where the general typically use transition metals in naming. So you'll usually have iron, you'll have lead, you'll have titanium. What other metals? Manganese as well, and chromium.
And
These are your typical ones where sometimes you'll have a 2 or 3, and some are even 4. It just depends on which one your professors are using. Once they give you that list, if they don't, you can ask them to specify, and that would help you more on narrowing because they typically don't use different ones for their exams or quizzes.
what if there's some that they give me that are not on the list? Because
Well, if they don't give you some on the list, then wait, so like they go over it, or
no, I have some compounds like IO, which is hypoiodite, and
yeah, so hypoiodide, that one is probably a part of your polyatomic, and you'll need IO in one of the namings that we're going to go over.
that's the thing on my list.
Yeah.
It isn't on it. The closest thing I have is just iodine. That's it.
Yeah, so hypoiodide, IO is a polyatomic or no?
I don't know.
So IO in this case is if your professor tells you about it, you should just note it down. Because
Maybe not, because there's a couple like bisulfide or sulfonal, HS, or hydrosulfuric acid. Like those are
yeah.
my
Yeah, so those are naming acids.
chrominate.
Yeah, chrominate is also a part of it. Chromic, there's chromate. So those are polyatomics that we're going to go over in the naming. What was it?
Permanganate.
Permanganate. Yeah, so that's also one of the polyatomic. So those are polyatomic ions.
So I have to memorize those as well.
Yeah, you have to know the polyatomic ions are one of the major ones your chemistry professors typically require or like recommend, and you should memorize them because they'll always be used in naming in word problems where you'll have to write it down with no reference as well. Okay, let's move on.
Yes.
So the first example problem we're going to do is I want you to write the molecular formula for iron 3. So that means it's Fe3 plus charge, okay? And when it combines with oxygen, O2 minus. And then I want you to name the compound. Do the same, so you'll write a molecular formula for barium when it combines with sulfate as well, then name the compound. Okay? I won't mark it here, you should do it yourself. Let's give you 5 minutes. Okay, here you go. So this is the answer that I wanted you to write down. So we wrote the charges on top, and then you cross them, and then you get Fe2O3. You would name it as iron 3 oxide. Remember, we had metal plus non-metal name. plus the suffix "ide." So oxide. And then for the example, second example is barium sulfate. So SO4 is a polyatomic ion. This is what you'll refer to. So you should know the assigned charge of -2 with it. And when you cross them, since they cancel each other out, you don't have to add any additional numbers. We have a 4 here, and that's because it's already a part of sulfate. SO4. If there was a charge on this, let's say, we would have to write it as SO4 with parentheses and then the charge, like let's say 2. Questions? Let's say Josie or Francis, any questions, or we will move on to problems.
We can move on to problems.
Okay. Let's go to the problems then. So the next one is I'm going to give you a set of problems. What I want you to do is you guys are going to write let me see the second one. So can you guys write the molecular formulas and name the compounds? Okay. So how about you tell me what you got?
Okay. For the first one, I put CaO, calcium oxide.
CaO, calcium oxide. Yes, that's correct. You can just walk me through the next ones. So B?
You put zinc 2, so I assume that zinc has a +2 charge.
Mm-hmm.
Also put sulfur 2, so I assume sulfur has a -2 charge.
Mm-hmm.
So I just put ZnS, zinc sulfide.
Okay, good. Next one, you can just walk me through.
Sodium has +2 charge, so it's Na. OH, hydroxide, has a -1 charge, so it's OH parentheses, and then 2.
So sodium should be 1 charge, I think, right? Yeah, sodium is in the first periodic table column.
It's just plus.
Yeah, so it's just an Na plus. Plus OH minus zinc 2 plus sulfur 2 minus. So NaOH and it's sodium hydroxide?
Yes.
Okay. Next one?
This one is silver phosphate. Silver, from what I remember, has a +2 charge, but I don't know.
Mm-hmm.
So it's Ag3, and then phosphate, which is PO4, has a -3 charge. So there's 2 of those.
So silver phosphate. Let me just. Silver phosphate, actually, the Ag is a plus charge and not 2.
Probably since it doesn't have a number next to it.
Yeah. So then your form, it should be Ag3 PO4
Mm-hmm.
and then silver phosphate. Okay. Can you tell me the last one?
Yes. So barium has a +2 charge, so it's Ba, and then nitrate is NO3. NO3 has a -1 charge, so BaNO3, and then there's 2 BO3s. I mean NO3s.
Okay. Like that?
Yes, and it's barium
So,
nitrate.
yeah. Okay. Good job. They're all correct. So it was only one was that charge on the silver. Okay. Any questions on these, or we'll go to the next set of problems?
We can go to the next set of problems.
Okay. So the problem 2, what I just want from you is to give me the molecular formula. So 5 minutes.
Okay.
Okay, let's go over them then. So you can just tell me your answers for A through D.
CO, cobalt 3,
Okay.
phosphate, PO4, 2.
2. Yep. Correct.
Iron,
2 plus.
mhm.
Okay. So iron, you did Fe.
Oh yeah, Fe, 2,
Mm-hmm.
parentheses, SO4, 3.
Yep, correct.
And then last one, AgNO3,
Okay. Yes, correct. And then the last one, calcium chloride.
Cl2.
CaCl2. Yep, that's right. Okay. That wasn't too bad, right?
No,
So
also,
you'll get, yeah.
I don't use like my periodic table of elements. I know I should, but I don't
Mm-hmm.
really, I don't even look
No.
at atomic ions. I have like
Uh-huh.
a flashcard,
Yeah.
and I love this flashcard.
Yeah, I would write. I used to do mine on my on flashcards too, the polyatomics. I would do, but once you get the hang of it, keep on referring to like silver, calcium, and the other common ones. You're going to memorize and remember what charge they have
This one is just
over time.
like a very general overview of ionic compounds, molecular compounds, and acids. It has all 3 on the sheet, so it's very like general.
Yeah.
But just with
Mm-hmm.
that, it reminds me like, oh, this goes into this category, so it should follow these rules.
Yeah, that's good. Good job. You're more prepared than I was when I was doing it. I got better. So the next thing we'll go over is non-metal compound naming.
Yes.
So how to name them, where it's basically you have the prefix. The prefix is one of these right here, the numbers. You're labeling them based off of how many elements, like atoms, there are. And then you have a second prefix. You'll also use this table of prefixes for the second non-metal element. And then with that last one, you'll add the suffix "ide." So an example would be diphosphorus pentoxide. The di comes from this 2. The pent comes from the 5. If you notice, you do drop the A here, but that's because it's next to an O. So that's why you have pentoxide.
You would also do that for like hept and octa, right? For some of
Yeah, so heptoxide. Instead of you wouldn't say pentaoxide. Yeah. So we'll go on to the next one. Remember this table. This table is useful, especially for non-metal naming.
I feel like I have memorized
Yeah.
up to 8. I always
Mm-hmm.
forget 9, and then I remember 10.
10. Yeah. Nona. Nana.
I think I should just think like Nona, 9, Nona.
Yeah.
Similar.
If you think about it, so Nona is similar to spelling 9, except it's replaced with the opposite, like, what do you call them again? I forgot.
That's fine.
It's the AEIOU thing, except you have the opposites. Okay, so for the problem set 3, what I want you to do is to name the following compounds.
Okay.
Just let me know when you're done.
Actually, can I just like challenge
Yeah.
myself? Not look at my card or my periodic table.
Yeah, do it.
Right now. Okay, so
I will.
3 is sulfite.
So sulfite. Okay.
Okay, so P phosphorus chloride, 3 chlorides, phosphorus tetrachloride. No.
Tetra. Is it tetra?
Trichloride.
Trichloride. Okay.
Tetra is like 4 or 5.
So
Penta. I know
you
that.
got half of this right.
Okay. And
So I'll explain after. So we can just go through them, okay? So PCl3. Tell me that one.
oh, you forgot the phosphorus part.
Okay, I haven't written it yet. Okay, phosphorus. Okay.
Trichloride.
Chloride. How many?
Chloride.
Trichloride.
Yes.
Okay, next one.
Nitrate.
So is it nitrate or is it nitrogen?
Nitrite.
Okay, so it is actually, I'm just going to correct this. I'll explain the A. It's nitrogen. So if you go back to here, remember that we don't change the name of the first one at all. So you just have the prefix with the name of the element. If you need a prefix. It's, you change the ending for the second nonmetal. So it would be nitrogen dioxide.
Okay.
Okay, so let's do D.
Phosphorus. Pentasulfide.
So pentasulfide, how many phosphorus do you have?
2. Would it be diphosphorus?
Yeah, so it'd be diphosphorus, pentasulfide. Okay, the last one?
Carbon dioxide.
Yep, carbon dioxide. You can write it as well, mono or monocarbon dioxide. So the error in your first one is that it isn't sulfite, but it is sulfur. Just sulfur. So I think it was confusing. It was throwing you off because usually you see like SO4 minus, 2 minus, and that's like sulfate, right? So if it doesn't have a charge, then it can't be sulfite. Because polyatomic ions have that additional charge that gives them that name.
Okay.
So this one you only have sulfur. Yeah. Okay.
Okay.
Okay, let's go to the next one. So now I want you to write the molecular formula for these.
Okay.
Based off of their names. Do you think you're done? Yeah.
Yes.
Yes? Okay, let's go over them then. So tell me the first one.
Okay. I'm a little confused, but it's
Okay.
BR3.
Yep, you're correct. And that's because, so this one we weren't doing anything to trick you or anything. It's pretty straightforward because this is non-metal only names. So it's just, yeah, so boron and you have bromine and there's 3 of them. So that's why it's tribromide. So that's why you have BR3.
For me, the thing that was confusing is I thought boron was a negative charge and then Br was also a negative charge. So
Yeah. So that's why, so we put it into this section because it's non-metal only, so you don't have to, there's no conflict between it in that sense. Okay, so what is B?
Xenon Xe fluorine 4.
Okay. Oh,
It's just
F4. Yeah. Okay. Can you tell me C?
Cl2O.
Cl2O. Yep. Okay. The last one?
CCl4.
CCl4. Yep, that's also correct. Any questions about them?
Nope. Just
Okay, so
negative.
okay, yeah. So that is when periodic table comes in to double check. So the last part that we'll be doing covering is acids, naming acids. So this is kind of when you have that iodate come in, as well as like sulfuric acid. So this is how you name acids. You have your binary acids, and that's with the H plus nonmetal. I'm naming as nonmetal. You don't have to add anything different. So oxyacids, and they're with the hydrogen with the oxyanion. So what that is something with an oxygen, and it ends with the term ate. And the similar case with, well, it's just it's an anion, really, an anion. And it ends with "ite." So did you ever learn like "ate"? This is how I learned it. "Ate." As "ite." There.
I learned that "ide," if an anion has "ide," then the acid name has hydro and "ic." If an anion has a suffix that's "ite," its acid name has an "us." And then if an anion is "ate," it has a acid name with "ic."
"Ic." Okay, I might have mixed it up. Sorry. Let me see. I think I was writing notes. Okay. "Ate," yes, "ate" is "ic." My bad. So "ate," "ic," "ite," "us." Okay. So next one. So this is with the ending. My bad. So hydro with binary is binary with "ic" plus the acid. "Ate" also with "ic" with an acid. And then the other one is "ite" is with "us" and an acid. So the differences between binary and the oxyacids is it uses a nonmetal in the base name.
That makes sense.
Yeah? Okay. So my first one for this problem is, can you name all these acids?
That's chloride. So chloride would be hydrochloric acid.
Okay, correct. Hydrochloric. Okay, the next one?
NO3 is nitrate. 8 has an "ic," so it'd be nitric acid.
So nitric acid. Yep.
I think that one would be chlorine dioxide. Ide gets a hydro-ic, so hydro.
So what is, let me ask you this, what is ClO2 minus?
Is that like perchlorate or something?
It's chlorite.
Chloride.
So it's I2 is. So what would it be?
Chlorous acid.
Yeah. The chlorous acid. Okay, so the next one.
SO4 is sulfate. 8 plus an "ic," sulfuric acid.
Yes.
What's the difference between this one that's H2SO4 and one that would just be HSO4?
So HSO4 would be sulfurous acid. Oops, I spelled it wrong. Purous acid. Because that would be SOH. It'd be HSO3. Because there's sulfite.
No, but what if it was HSO4?
So it can't be. So H is a plus charge and SO4 is a 2 minus.
Okay. All right, that makes sense.
So yeah, so it can't be HSO4. Okay, the last one. What is the name of CO3? So CO3, to remember this one, think of nitrate. So NO3 is nitrate. So what would CO3 be?
Carbonate.
Yeah, so it'd be carbonate. So if an 8, what would the acid name be?
Carbonic acid.
Yeah, so it'd be carbonic. That's it. So here's another one. Now the reverse, can you give me the molecular formula?
Hydrofluoric acid. That would be HF.
Okay. You can continue, just continue on. Hydrocyanic acid. What is cyanide?
CN. So HCN.
Yep. Chlorous acid. You just did that earlier, actually.
HCO3.
So HCO3 was carbonic acid. It's chlorous acid. So HCl,
Cl.
what? Now this is chloric acid. It's hydrogen chloride, actually.
ClO.
O2.
Yes.
So ClO2 minus is chlorite. Okay, so phosphoric acid. So think of the name of the polyatomic and which one corresponds with it.
HPO4. Would it be H3PO4?
So yes, H3PO4. Because it's H plus and PO4, 3 minus. Okay, so the last one, E, is H2.
SO3.
Sulfurous acid. Oh, my bad. So earlier the H2 is still SO3, 2 minus. Okay, so that's the end of these problems. Since it's almost 8, I'm giving you the option. Do you want to finish the last 2 slides? I think it's for 9 more problems. Did you want to do them or did you want to end it now for the workshop?